Sıradaki konuşmacımız Canonical Ürün Müdürü Tytus Kurek olacak. Canonical'da ürün müdürü olarak görev yapan Tytus, Canonical'ın bulut altyapısı alanındaki ürün ve hizmetlerinin gelişimini yönetmektedir. Başlıca ilgi alanı dünyanın en popüler açık kaynaklı bulut platformu olan OpenStack'tir. Icehouse versiyonunun piyasaya sürülmesinden bu yana OpenStack topluluğunda yer alan Tytus, Sunbeam, OpenStack Charms ve Designate gibi projelere aktif katkıda bulunmaktadır. 2020 yılından beri OpenInfra Vakfı Yönetim Kurulu üyesidir. Tytus doktora derecesini 2018 yılında telekomünikasyon alanında onur belgesiyle almıştır. Şimdi konuşmalarını yapmak üzere Tytus Kurek'i sahneye davet ediyorum.
Hello, good afternoon. I hope you are still enjoying this amazing show. I know it's getting late, but please bear with me for another half of an hour. So my name is Tytus Kurek. I'm a product manager at Canonical. If you haven't heard about us, we are the company that stays behind Ubuntu. I'm pretty sure you've heard about Ubuntu. So we provide engineering resources for it, we release Ubuntu, we provide security updates, and an optional commercial support for enterprise customers. So I need to admit that when the OpenInfra Foundation decided not to organize a global event this year, we decided to split the efforts, and I have a colleague attending the OpenInfra Days France, like in 2 days. I have another colleague presenting in Hungary, I believe in 2 weeks. But when my talk got accepted for the OpenInfra Days Turkey, I said, no, I'll do it myself, I'll deliver it myself. Why? Because I think Turkey is one of those countries that is going to play a crucial role in open source adoption and in the OpenStack adoption in the next few years. And second of all, well, it's in Istanbul, and I've never been to Istanbul, and I've always wanted to visit this beautiful town, so I'm here. So I'm going to talk about OpenStack Public Clouds, making an argument why you should consider becoming a local cloud service provider. So let's start with that. Let me present those 7 points, and then we'll go a little bit deeper into each of those. So first of all, there is a demand. You'll see on my slides that there are already hundreds of organizations that are actually providing this type of services for local, for regional markets. So there is a huge demand. Second of all, safeguarding national interests. We're living in very interesting times where no one knows what happens with the data that are being stored in all of those hyperscaler clouds, right? So if you put your workload on like all of those 3 big American tech giants like AWS, Azure, Google, like no one knows whether this data is actually secure, whether it's private. So safeguarding national interests starts playing a crucial role. Others are already doing it. Again, you'll see on my slides, I'll present examples from companies and from markets and from countries that have already decided to build their local public cloud infrastructure based on OpenStack, so you wouldn't be the first one. It's easier than you think. Some of you have already experience with OpenStack. I know some of you are new to the community, so you've probably heard about OpenStack being like this kind of a very complex ecosystem combining, various pieces of open source, but at the end of the day, others are doing it. So it's doable, and with the use of proper tools, I can guarantee that the overall complexity of OpenStack can actually be tamed. You already have an infrastructure. If you're a telco, if you're a service provider, even if you're like a web hosting type of a company, you already have all the necessary infrastructure to consider building a local regional public cloud. You have data centers, you have internet connections. Well, you maybe need just more hardware, but you'll figure that out as you go. You already have a brand. You've heard talks from local mobile providers, so you all know those providers, right? Like imagine how easy is it to establish a brand around something like that plus public cloud services, right? So people will find you, people will recognize you, they will know it's coming from you. And last but not least, there is a business case, and I'll demonstrate that. So investment wouldn't make sense until you couldn't expect a return from it. So there is a valid business case behind becoming a local public cloud provider. So the agenda of my talk is briefly as follows. So I'll start with some challenges, with an overview of some challenges associated with using hyperscalers. Then we'll talk a little bit more about OpenStack Public Cloud implementation. We'll dig a little bit deeper into cause analysis of hyperscale cloud versus your own cloud. Then I'll demonstrate some case studies from Canonical's reference customers who built a regional public cloud infrastructure based on Canonical OpenStack. And we'll wrap up with how Canonical OpenStack can actually help you become a local cloud service provider. So let's speak a little bit about hyperscalers, right? And first of all, like by hyperscalers, I mean like all of those big public cloud providers, right? Like those who we can say basically dominate like 99% of the market. And those are all of those big American corporations. It's AWS, it's Azure, it's Google, but there are also some smaller players, but they are still considered hyperscalers. So first of all, hyperscalers provide an almost infinite elasticity, meaning that you can ask for how many resources as you actually need, right? And you can grow almost ultimately unless you would wish to consume like, you know, zettabytes of data or whatever, right? Which normally does not happen. They also provide higher level services, right? So you can get like things like AWS Lambda functions, right? To build a serverless architecture for your applications. And this is a large ecosystem consisting of functions like virtual machines on demand, bare metal on demand, containers on demand, supporting all typical CPU architectures. There's a number of benefits. But at the same time, hyperscalers come with a lot of significant challenges. So first of all, cost, right? Whoever has used public clouds knows how costly it is in the long run, and especially when running workloads at scale. At some point, there's no justification behind doing that anymore. Lock-in is another challenge, right? Like once you start using, let's say, AWS APIs, you kind of lock into them, right? Like it's very difficult to move to any other cloud platform later on. Performance, unless your company is located in one of those regions where hyperscalers have their own data center, you will suffer from performance degradation, right? Like this is especially relevant for regions like South America, Middle East, Africa, but I believe it might be also a challenge in Turkey. Lack of sovereignty, again, safeguarding national interests. A lot of organizations are awaking to a fact so that the data that they store in public clouds are not secure, are not private. Like the cloud operator still has an insight into those data and cannot guarantee that this data is not going to leak. The risk of monopolies, again, you can see what has happened, right? Like the free American corporations have kind of dominated the whole market. And the risk of monocultures is like your teams get used to a single cloud technology and they do not explore the other ones that are available out there. So let's talk a little bit about OpenStack and how it can actually help to bypass all of those challenges that we've been seeing with hyperscalers. So in order to understand that, let's get back to 2010, when OpenStack was born. So at that time, AWS was really the only public cloud game in a town, right? Like at that time, if people were talking about moving to a cloud, they meant moving to AWS because there was nothing else, right? But and at that time, there was no solution to build public clouds using open source, right? So again, the cloud meant AWS because there was nothing else. And at that time, Rackspace and NASA decided to join their forces, and they brought two very good use cases for cloud computing, Rackspace bringing the public cloud use case, and NASA bringing the private cloud use case, and this is how OpenStack was born. So Canonical has joined the OpenStack community in the very early beginnings, and we've been involved in the OpenStack development for years. We are actually the third biggest contributor to the OpenStack in the upstream in terms of the number of commits across all of the releases from Austin to Caracal. And this is how OpenStack looks like these days, right? Like it has grown significantly. It is one of the most actively developed open source projects in the world, as you could hear from Thierry's keynote today. It basically resembles the public cloud behavior. So you can get most of those functions that you would typically get from AWS, from Azure, or from Google. It has also got a lot of services around it, providing more sophisticated functions like bare metal provisioning on demand, Kubernetes clusters provisioning on demand, GPU, and so on. However, at Canonical, we take a little bit more opinionated approach into how we do OpenStack, and we evaluate every single OpenStack service before we decide to support it to make sure it's in a healthy shape. Because at the end of the day, it is an upstream project, and some of those services are supported on a best effort basis. So unless we know the service is in a healthy shape, it does not land in the portfolio of what we support as a company. On the adoption side, this is how OpenStack has grown for the last 14 years, right? So if you hear stories like OpenStack is dead or OpenStack has no future, well, take a look at this graph, right? These are the real data behind OpenStack. It comes from the OpenStack user survey that is hosted by the OpenInfra Foundation, right? So, of course, those who are not successful with OpenStack will claim it's dead, right? But we all know it's not, because the data speak something else. And now taking a look at the public cloud footprint, so there are more than 300 organizations all over the world who already provide public cloud services on top of OpenStack. I do not see Turkey on this list, right? So think about that. There is a huge market for your country, there is a huge market for your companies to establish yourself as this kind of a regional public cloud provider. It comes with a number of benefits for end users. So first of all, they're not locked into a single public cloud technology as they are with hyperscalers. They get low latency through local deployments. Again, if I'm a company based in Turkey and my public cloud provider is based in Turkey, the data center is local. Like the data does not need to go beyond the boundaries of a country. So I can expect way better latency. Data sovereignty through local companies, again, the data does not leave the boundaries of a country, and only the cloud operator in my country has an insight into this data. It's a healthy market for smaller actors. I think it would be a little bit naive to expect that you will be able to immediately compete with the hyperscaler clouds. It can happen over a decade, right? But it won't happen in a day. It is still a healthy market, though, right? Because, as we said, there is a valid business use case behind that. Users can get, they can still get infinite elasticity through multi-OpenStack clouds. Like a single OpenStack cloud cannot grow up to a scale that AWS-hosted data centers grow, but you can still get more smaller clouds and manage them from like a single dashboard, from a kind of a single pane of glass. And this also helps users to evolve towards hybrid clouds, having the same APIs for their public cloud while using exactly the same APIs for their private cloud that would be hosted by them on their premises. But we've talked about the users. How about you, right? Because I'm trying to encourage you to become a local service provider. So this also has to come with benefits for you. So first of all, you don't have to reinvent the wheel, right? Like you use the upstream project that is well established, that is proven to work at a scale. So you just consume all the goodness that the entire open source community, the entire OpenStack community has contributed upstream over years. It's a permissionless innovation, right? Like OpenStack is usually at the forefront of everything that's happening in the industry, both on the hardware side and on the software side. So, and nothing blocks you from actually becoming a contributor to OpenStack too. Knowledge sharing. You join a community of other companies like that who are providing exactly the same services. So it works. It is a community, right? Like you can share knowledge, you can exchange your experience, and also, again, contribute upstream any innovation so that others could benefit from the work that you contribute, and you could contribute from the work that others, you could benefit from the work that others contribute. And last but not least, again, there is a very valid business use case. So let's talk a little bit about that. So in the following slides, I'll try to demonstrate how the costs shape between a hyperscale cloud and your own cloud. So what I have here is a number of charts that represent the costs and how the costs shape between these two types of environments. So we'll start with the CapEx cost. It's the initial cost that organizations have to pay when they consider a migration to a cloud, right? So obviously, there's almost a zero cost that comes with the usage of public clouds. All you have to do is to attach your credit card to the public cloud billing platform, and you can start consuming all of those infinite resources on demand, while if you build your own cloud, there's obviously a significant CapEx cost that you have to pay upfront. It is associated with the hardware purchase, it is associated with the data center rental, it is associated with the cloud delivery. However, on the OpEx side, like this is how the costs shape in a public cloud environment. They grow very fast. They grow really very fast. And the more virtual machines you run, the longer you run them, the bill is going to get like that. While if you build your own cloud, this is mostly how the OpEx shapes. So first of all, it's relatively flat. It's relatively flat. Assuming a fixed capacity, it is almost flat. And it is lower, it is way lower compared to this initial CapEx. So now if we add those two together, we get the TCO, a total cost of ownership. So CapEx plus OpEx. Again, public clouds, again, this is how it shapes. It's growing very fast. If you build your own cloud, it is, again, relatively flat, and it's definitely lower than the TCO associated with the public cloud. Now, if we add those two on a single chart, you're obviously going to see that there is a period of time where a hyperscale cloud is preferred, right? Like if you're a small company, if you're a startup, if you just run a couple of business applications, then there's no point for building your own cloud, and there's no point for you to becoming a cloud service provider for just a single company like that. However, on a scale, you're going to see that it actually becomes cheaper to host such a workload on your own cloud, and this is where you can actually get the benefit of being a local regional public cloud provider, because at the end of the day, this is your profit margin, right? So the more companies you onboard as a public cloud service provider, the more workloads you run on your cloud as a local regional public cloud service provider, the higher your profit margin is. And I'm going to present some data from Canonical's cloud pricing report that we conducted 2 years ago, where we considered 3 different scenarios, a small-scale one, a medium-scale one, and a large-scale one, to demonstrate how the costs shape when trying to run the same workload either in a public cloud or on a private cloud that's based on Canonical OpenStack. So we conducted this research using the official TCO calculators that you can get at AWS, at Google, and Azure. And this is mostly how the cost shapes. So let's start with a small-scale scenario. It's an internal CRM system. It's a very simple workload that consists of just a database and a web application. So obviously, if that would be the only workload that you would onboard as a local public cloud service provider, then there is no business justification behind doing that, because at the end of the day, the cost associated with running your own cloud would be way higher. But let's consider something more complex, right? So this is an online banking system, and again, it comes like from one of our customers, you know, like those are the requirements that they had, right? So if you go at the scale of, you know, thousands of vCPUs, right? If you onboard a workload like that, then you can see that the cost associated with running this workload in a public cloud becomes way higher right after the first year, right? So again, this is your profit margin. This is how much you can earn by becoming a local public cloud service provider for such a company. It's just a single company, single workload, again. And let's talk about like the most complex scenario that we consider. So it's like a video streaming system, right? Like it consists of data warehouse, data lake, data analytics. It has a video transcoding engine, a web application. We go at the scale of tens of thousands of vCPUs, right? So you can think of it like onboarding like a very big local video streaming provider or many more smaller. This is how the profit margin is, right? So this is how much you can actually earn, again, by becoming a local public cloud provider. So just to prove that we're not talking about scientific data only, let's take a look at two case studies from two different Canonical customers who actually built their own public cloud infrastructure using Canonical OpenStack. So I'm going to start with the first one. It's Nayatel. They're one of Pakistan's biggest service providers, and their motivation to become a local public cloud service provider was to offer better latency to the local market. So that was the primary motivation they had. And for this purpose, they used Canonical OpenStack. They also used Canonical Kubernetes on top of that. And they run it under a single support subscription. So the good thing with Canonical's offering for cloud computing is that you can actually get a full commercial support with guaranteed SLAs and 10 years of security maintenance under a single subscription that's charged per node. So we do not charge like separately for OpenStack, separately for Kubernetes. No, it's just like one subscription that covers all the layers of the stack. And here is a different example. So it's a company called Firmus, who's an Australian cloud infrastructure provider. And their motivation was purely economical, right? Like they understood that there is this business use case behind that, right? Like they did those calculations themselves, and they thought like, yes, this is how we could actually make money, right? Like it makes sense to become a local public cloud service provider, and they did, and they're quite successful with that, and they have quickly become one of the leading regional public cloud providers with high-performance computing and AI/ML focus as the primary use case. By the way, they use a lot of GPUs for compute acceleration, which is obviously fully supported with Canonical OpenStack as well. So to wrap up my session, let's talk a little bit about Canonical OpenStack itself and how it can help you become a local cloud service provider. So first of all, what is Canonical OpenStack? Well, it is an OpenStack distribution, right? Like, so it is fully upstream, it is fully open source. It, as I said, takes a little bit opinionated approach towards what's available in the upstream. If something is in a healthy shade, we aim to fully support it under Canonical OpenStack. If it's not, then we rather consider alternatives. But first of all, it's fully automated across all the layers of the stack, from bare metal provisioning up to applications orchestration. It is cost-effective, helping you to get the best cost per resource metrics on the market. So cost per vCPU, cost per gigabyte of RAM, cost per gigabyte of raw storage. We try to reflect all of those best metrics in the reference architecture that we provide for the platform. It is highly performant, meaning that it supports all of the EPA features, it supports GPUs, it fully supports SmartNICs and DPUs. I'll talk a little bit more about that in a second. It comes with a rich partner ecosystem, enabling you to integrate with the platform of choice in terms of hardware and various third-party softwares. And it's enterprise-grade, meaning that it comes with the with all the benefits of Ubuntu Pro, which is the commercial subscription that you can get on top of open source free Ubuntu operating system. So the full automation is provided by two essential pillars. One is Canonical Mass. So Mass automates everything related to hardware. This is basically a component that turns your data center into a bare metal cloud, right? So if you're setting up a cloud, you want your bare metal processes to be fully automated so that you can just click and get a machine with the operating system installed and configured. This is something that's provided by Mass. And Juju automates everything on the software side. So this is the orchestrator. This is the system that spins up OpenStack, sets up all necessary relations between various OpenStack components, and configures them accordingly. So Canonical OpenStack is cost-effective. If you take a look at this graph, what it demonstrates, it's like a typical budget associated with the private cloud infrastructure maintenance. It consists of 4 pillars: hardware and facilities, software license and services, internal operations and maintenance, and R&D and change. The first 3 represent raw costs. It's like it is just a cost and there's no benefit from that, right? Like only the R&D and change is this part of a budget that at the end of the day helps you to innovate and be more competitive on the market. So the value proposition behind our product is a decreased TCO, right? By using an optimal architecture for OpenStack deployment, by offering our services at a better price compared to the primary competition, and investing in total automation around bare metal, around hardware provisioning, and around software orchestration, we can significantly decrease this portion of the budget, leaving way more space for innovation. It's a highly performant infrastructure that, again, comes with all of the typical EPA features. It fully supports GPUs, both GPU pass-through and GPU virtualization. And it also supports hardware offload to SmartNICs or DPUs to free up cycles on the compute side. And we've been talking a lot about compute acceleration today, right? So this kind of a triangle between CPUs, DPUs, and GPUs is likely how the future of data center is going to look like. So the platform is fully ready to embrace all of this innovation coming on the hardware side. Interoperability, so first of all, you can deploy it according to all typical cloud architectures, with our preference of that being hyper-converged, but you can also do converged or a fully disaggregated architecture. You can run it on all major silicons and all leading hardware platforms. On the networking side, we support all leading software-defined networking solutions with the preference of using OVN as the best-in-town, open-source, software-defined networking solution. And on the storage side, we provide Ceph by default, but we can actually integrate with any Cinder driver that's available in the upstream. And last but not least, it's enterprise grade, meaning that it delivers all of the benefits of Ubuntu Pro, as I said. So first of all, it comes with a predictable release cadence. We ship new versions of Canonical OpenStack every 6 months, almost at the same time when we ship new versions of Ubuntu. The versions that come by default on our LTS version of Ubuntu come with 5-year security commitment for free, and under Ubuntu Pro, 5 years of commercial support and additional 5 years of security maintenance. It also comes with the hardening profiles as defined in typical hardening guidelines like CIS or DISA-STIG to help our commercial customers become compliant with those standards. So that's mostly it from my side for today. I'd like to thank you very much for your attention. One final thing is that we are hiring. We are present in 60+ countries all over the world. We do not have a central office. We're a remote-first type of a company. So if this is something that would interest you, I'd encourage you to get in touch with me. I'll be here until the end of the event. You can also find me on LinkedIn. Or you can also go to canonical.com/careers and find a job offer that would interest you the most. Thank you very much.